Alright, hello and welcome to the next week. This week we're going to talk about files, or sometimes called streams, and this is going to be a really laid-back week, I think. It's smack in the middle between two difficult topics, and so you deserve a bit of a break, so that's why we're putting files right here, I guess. So let's get started. First, I want you to meet my cat. His name is Alonzo. I call him Lonzo for short. He is named after Alonzo Church, who he invented this thing called the lambda calculus, which is the most beautiful model of computation that has ever existed or probably ever will exist, and it was something that I had to get very familiar with during my time at UCSB as a grad student. So it really helped me in my little subfield of computer science that I studied. And also, if that doesn't matter to you, he was Alan Turing's PhD advisor, so he's at least famous by association. Alright, so that is my cat. We will see him again later in this set of slides as well. Next, I want to talk about the second midterm. So it's almost week 12, and week 12 is when the midterm is. Okay? So we had one at week 6, and now we're having another one at week 12. So 2/3 of the way into the class. So let's go to the page. I was looking up Swedish words for a reason. This one. So again, I'll have a review and then I'll release an extra credit assignment. Those are not ready, but the midterm info page is what I want to show you right now. So it's going to be available week 12, Thursday and Friday, just like for the first midterm. Okay? Same time frame as well. Thursday is the 29th, the 30th of October is the Friday. So you can start any time. Again, you have an hour and 15 minutes. So make sure to start at least at 4:15, of course, on the last day. Take place during lab. And so here are the topics. Lectures up through week 11. Obviously, everything in this class builds on top of itself, so you might definitely expect to write a loop and things like that. So it's all kind of coming together. And next week, I'll be talking about this concept called recursion. And if I ask any questions about those, I don't want to be evil and like test you on something that I just taught you, that you didn't have a lot of time to practice. So if I ask you anything about recursion, which I'll talk about next week, those questions will be worth very much. So I'll try and save most of those recursion questions for the final. Okay? So files, therefore, the things that I am explaining to you this week will be the last major topic that will appear on the midterm. Okay? And then stuff from your Xi books, so everything from chapters 5 through 9 will be fair game for the questions, as well as labs 4 through 8. So there's one more that's going to come out, and that will be the last one that I will take questions from, or the topics from at least. And then the format's the same as last time. You'll expect some multiple choice questions, and then some coding / fill-in-the-blank questions. Okay? It's all the same. Feel free to make a giant cheat sheet. I'll try and make you one for a few things for my review video, and that'll be that. Okay, so that's the midterm, and let's now return to the slides. The first thing I want to do, because I didn't have enough time last week, is to give you a nice motivating example of why you might want to use the heap if you don't feel comfortable yet with that thing called linked lists that I talked about. So here is a motivating example for heap arrays. Let's pretend that the user wants to give us a bunch of numbers, and we have no clue up front how many numbers they're going to give us. That is the greatest case for heap arrays because we can make those on the fly. Okay, we can make an array on the fly of whatever size we want. And it can be exactly that size as well. So we can like get in, okay, how big do you want this array to be, user? And we can be like, oh yes, all right, here's the array. Equals a new int of that size n. So immediately we can make an array of a given size on the heap. If you wanted to make it on the stack, it wouldn't work. You'd have to do it up front. Like, all right, I'm going to make an array, and hopefully the user is going to give me something within 100 numbers. If the user goes over, then the entire program gets messed up. And this is technically what vectors are doing under the hood. And so if you want to understand vectors, this is a good example. extending a dynamic array that has been made on the heap. So that's enough words. Let's get an example. All right, vim heap arrays.cpp. Let's pretend that the user is going to give us, is going to enter the following. We'll first enter n, which will be the amount of numbers that the user will enter next. So first the user gives us how many numbers they want to input. So we'll get that. Just like that. So now we have it. And now we're going to use that n to make an array on the heap. So we'll say int star arr, because the heap gives us back a pointer to the start of this memory that it made for us. Int star arr equals new int of size n. So we just made a brand new thing on the heap of size n, and before we end this program we should delete it because we're done with it. It's a good habit, even though it'll get deleted by the operating system. So maybe I should explain that. Technically, all our program's memory is about to go away because this program is about to end. So we don't actually need to delete AR, but it's good programming practice. Okay, we're taking care of our memory. All right, so now we can just read those n numbers and put them in that array. So, I don't know, 4. We can use it like an array, even though it's a pointer, remember that. Get an int, and I don't know, maybe we can then print out the sum or something. So I'll do the following. Sum equals 0, and then we'll add in the current value to the sum, and then we can be like sum Okay, so let's make this. All right, so let's say we're going to enter 5 numbers. So the user entered 5, I did it, and then we just made an array of exactly size 5, no more, no less. So it's even better than a vector. It's slightly more efficient because we say exactly what we want. We don't have to resize anything. So then we're going to read the n numbers, so we have to now type in 5 numbers, like, I don't know, 42, 17, negative 18, 19, and then negative 19. Who knows? It's like, okay, here's the sum. It's 41. Beautiful. And then we're done with the memory that we just made for ourselves, so we're going to delete it, but it could potentially exist for as long as we want it. Okay? The heap memory is not tied to a particular function. Okay, so that's my example of heap arrays, and now let's get on to files. So the first thing that I want to teach you how to do is to write to a file. So let's talk about that. So right now, we have essentially just one way of outputting things. We see out. We tell the user, all right, well, I'm going to display things onto the screen. But we have another place in our computer that we haven't touched yet. We have files. Like I can write a file, a.txt or something. And then the user can go and look at that whenever they want, as much as they want. Let's write to files, okay? OFStream is the type of it's a certain class. It's like string in C++, just another class that creates a writer. So you make an object of type OFStream. It will, and you give it the file that you want to write to, it will write to that file for you. Okay, so it does all of this file writing business, which is fancy work underneath the hood, and it gives you the ability to just write to a file. So it lives in FStream, and OFStream stands for output file stream. So you can think of output file, that all makes sense. Stream might not make sense. Stream just means like an abstraction over things that you can input and output to. So you can think of it like, metaphorically, you're sending characters to this thing called a stream, and eventually it can, like, you can input to it, and you can output to some file or something. So it's an abstract thing, and we call it a stream. You can just pretend it meant file for all intents and purposes. All right, so let's look at the documentation then for FStream. So it's right here, input output FStream, and then OFStream is one of the classes that lives inside of that. So we go to OFStream, and a lot of fancy information, but probably the best place to look is the constructor. How do you make and use an OFStream? And you scroll down, it gives you a nice example. It's like, oh, okay, you can use OFStream, OFS, and you can give it a file, and that will open things. Or you can just declare one and then give it a file later with the open function. So you can use the open function or the constructor to open a file. You give it the file name as either a string or a C string, and then you can use operators, now that we know about them. You can use these less than, just pretend it was cout and write to a file, okay? As if it was cout. You can use that same thing to write to a file, okay? So there's something in common with OFStream and cout. Interesting. Okay, so let's write 1 to 10 to a file. Okay, so we have to include FStream, and then we have to make an OFStream object, open the file name that we want to open, that we want to write to, and then write to the file, pretending as if it was cout. Okay, so that's again a lot of words. Let me give you an example here. So I'm going to make a new file called, I don't know, fstream.cpp. Why not? So the first thing we need to do, include a few things. FStream, I think, is definitely what we want first of all. I'm not sure if I need string yet, but I'm going to include it just in case. So here's what we can do. We need to pick a file name to write to. It will write to the file name in the current directory in which we run the program. So let's pretend that the file name we want to write to is, I don't know, output.txt or something. Or maybe we'll call it 1 to 10.txt. Okay, that'll be the file name that we write to. Okay, so first we make an OFStream object. I just call it OFS usually. Then we give it the file that we want to write to. We say ofs.open. You could also do this in OFS's constructor. You say ofs.open, then the name of the file, 1 to 10.txt. Open the file for writing. And now we write to it as if it was cout. No, actually, how about 1 to 10? Then we'll do, instead of cout, I, new line, we can change this to OFS. It works just like cout. Except it won't display anything to our terminal. It'll just write to a file. Isn't that cool? And then we're done. OFS.close, close the file when we're done working with it. So that's the pattern. That's the very last thing. Okay, so what happens is, wherever you run this program, it depends on your current working directory. When you run this program, it will make a file called 1 to 10.txt in your current working directory. And then it will start writing the stuff that we wrote, 1 to 10. Okay? That's not too bad. I'll call it ofstream. So now I have /ofstream, and notice I have many files, but I don't have one called 1 to 10.txt. Oh, oops, sorry. There I go. If I say ls now, oh man, do I suddenly have 1 to 10.txt? What? Not sure what this file is. I'll have to look at that later. But now if I look at that file, I can say vim 1 to 10.txt if I wanted to. Isn't that beautiful? It's got 10 lines. It's perfect. Another way to do it is just, there's a cat command that prints out a file to your terminal. And it prints out 1 to 10. That was the file. Beautiful. Right? Beautiful. So one thing I do want to say, it's a good idea to use that .close on a file, but it will also be closed for you at the end of the scope. So the idea here is that the OFS variable that somehow kept track of the file that we're writing to using fancy class stuff and operating system stuff. Eventually, it's just a local variable, so it's going to go away when main finishes. It's going to go away on its own, but it's a good idea to always close a file, just to get in the habit of that, even though it's going to be cleaned up for you, usually, because maybe another part of your program wants to access that file, and it won't have access if you still have it. Okay, that's one way to do it. I want you to notice that if I rerun the program, it will overwrite the contents of the file. So here I go, /ofstream, print it out using cat. It prints out 1 to 10 again. If I want to change this, like I can make it 15 or something, just briefly. Come on, there we go. Run it, print the file. Now it holds 15, it replaced it, okay? I can make it 10 again. And again, compile, run, it overwrites the file. It replaced it with 1 to 10 again. Oops. Sometimes you have files that you want to keep around. And you want to write to the end of a file. You just want to add to it. That's called appending. So, there's a way to do that. When you open your file for writing, open, there is a default parameter that you didn't have to give. There's a second parameter called the mode in which you want to open the file. We have made it out. We could also make it app, okay? App for append. And so it's very odd the way you do it. You say iOS base : And I think iOS : app also works. So to append, we have to say, oh no, there we go. Open in iOS space : app mode for appending. So now, I'm going to do the same thing. I'm going to make an OFS2. I'm going to open, I don't know, 120.txt or something, or maybe 1 to 5. That'll make more sense. And I'm going to print 1 to 5 to that file. So 1 to 5. Print it out to, OFS2. Technically, I can reuse OFS if I wanted to. OFS2.close. And remember a semicolon. And now, all I have to do is change this second parameter. I don't want to use the default one. I want to use iOS base : app. So now, the first time I run it, oops, where was I? There I am. The first time I run this program, remember it's also going to work on this 1 to 10.txt file, but that's okay. It's going to get here and it's going to write to 1 to 5.txt, which currently doesn't exist. So I'll run it now. Now I have 1 to 5.txt. If I print it out, we got 1 to 5. But I open this file in append mode, so if there's something there already, like there is now, rerunning this program will add to the end of it. It will append. Okay, so I can run it again, and again, it's going to change the file to add more things. Okay, so that's appending. iOS base app mode. Okay, that's appending to a file. Now, the next thing that I want to show you is the duality. So, OStream is a type. Okay, OFstream is also a type, but this is a weird, complicated C++ topic that you'll learn about in CSCI 41. But OFstream is also an OStream. This is like a more basic type. Okay, so if we go to the documentation, I will prove that to you. And this is why OFstream objects and cout are very similar. So OFstream, if I make this clear again. Oh no, why is it not? Can I reload? There we go. There's a little arrow. OFstream is an OStream, is an iOS, is an iOS base. So they inherit qualities of things. So OFstream is an OStream. And then let me go to iostream, and I'll click on cout. And oh man, cout's type is OStream. OFstream is also an OStream. It's just a more specialized thing. And if I go down to what an OStream has, it has all these things. It has an output operator. Oh shoot, that's why this works. That's why both of them do the same thing. When we give it words, it just either outputs to a file or it outputs to the screen. Okay? So let me say that OFstream inherits from. And you can read about this in your book if you're feeling so inclined. And what this means is it gets some of its qualities. OStream is a more basic type, and OFstream is like a specialized version of an OStream. That's a lot of weird words, but all I want to say is, because the types are similar, and OFstream objects have related types, they work similarly. And so you just notice that the operator output exists for both of them. That's kind of cool. Just, I guess, a sneak peek for CSCI 41. All right. So now, with all of that in mind, I want to give you an example of doing both. So if I write a function that takes as a parameter an OStream, we'll make it a reference for reasons. If I take it an OStream as a parameter, call it OS, inside of this function, I can say, oops, OS output blah, and it'll write to whatever OStream I gave it. So for example, if I ran write 1 to 10 with some OFStream object, too many parentheses, I know, then it'll write to that file. If I run that same function, and this is the beauty of that inheritance, the fact that OFStream and cout have a similar type in the hierarchy. If I ran it like this, and this is just like a line of code with a semicolon, if I ran it with cout, it'll also work. Isn't that cool? So for my last trick, I'm going to make a function. What was I exactly going to call it? Let me just copy and paste this. Let me confirm that this is all still working. Yeah. All right, so the idea is I'm going to encapsulate all this stuff. I'm going to be like, okay, whatever you gave me, it was some kind of OStream. I called it OS. Every OStream has an output operator defined for it. So I can use it to print to either the file or to the screen or to any other esoteric OStream that you have. Cout is an OStream, and so is any ifstream object. Okay, so cout is technically an object. It's an OStream object. Okay, so if I run this function now, it's going to work. So one last time, OFStream OFS3, OFS3.open, I don't know, 1 to 10 dash, how do we want to call this, with functions, .txt, because why not? And then once we're done with it, of course, we're going to say ofs3.close. We're going to write to it now by calling this function up here, write 1 to 10. We give it ofs3. Oh, I'm so sorry, ofs2. Don't know why I added 1. Oh, I've done something weird, I am sorry. I was supposed to put it right here. There we go. Then it is ofs3. We say write 1 to 10 ofs3, and that should work. Okay, so it's running this function to print to the file. Okay. So it expected not an OFStream, but an OStream, because an OStream, sorry. There are too many letters, and I apologize. Because an OFStream is an OStream. this will work. And so if I run this one last time, or second to last time, it's going to do everything it did before, but also make this new file and write 1 to 10 to it in a new way using those functions. So cat 1 to 10 dash with functions. We got 1 to 10, but also we can use that same function to also write to a cout. Okay. And so my final trick. This compiles. This will run because cout has a type. We just didn't know it before. It's ostream. Write 1 to 10 to cout. And so finally, we've been running this program. It gave no output. We're finally going to give it some output in a weird way. Okay? Because this function, it takes cout here. So OS will be set to cout. And so this will be as if we had said cout I, new line. Okay, so now it's finally going to write. It's going to print 1 to 10. Oh, I have to recompile, of course. And so it printed, it pretended that cout was a file, and really it is, deep down in the operating system. Okay, so I hope you can see why this is not too bad of a topic. This doesn't even require classes too much. So that is writing files. Obviously, you want to do the opposite as well. You want to read them. And do I have a type for you? ifstream for input. Okay, so ifstream stands for input file stream. And what it does is it reads a file, and it kind of pretends to be cin in a sense. So up until now, we've been able to get input from the user in a few ways. Using cin/getLine with cin. And then alternatively, so that will give us input as the program is running. Input from the user. User's keyboard as the program is running. Alternatively, we can use command line arguments. You remember those argc/argv, that stuff. And that will allow us to get input from the user, most likely their keyboard, before the program ever starts running. Those are your two options up until now, and now we finally have the third option. Read from a file. So, in essence, all you have to do is the same stuff. It works very similarly to ofstream. And cin, if those go together at all. So let me now show you that cin is an iStream, and ifstream, the more basic type of it, is iStream. Weird types abound. Alright, so here is fstream. It has ifstream as well. ifstream is an iStream, which gives it that input operator. Cin is an iStream, and of course, every iStream gets that operator. Okay, so you can look at the ifstream documentation. I encourage you to. It's very fun. You look at the constructor. How do you create an ifstream? Well, you give it a file again. Then we can get from it using the input operators. This one will work. You can get a single character at a time with get. We might use that later. You can get a line from the file at once. So I'll try and show you all of these if I can. And yeah, we again just open the file as normal. You can do it in the constructor or in the open function. And usually you don't have to give that second parameter because it's already correct. So you can give it a string, whichever kind of string you prefer to use, that represents the file you want to open. Okay, so let us read the first 5 lines of a file or something. And let's assume they have numbers. And then we will sum them and print the sum out. Okay, so that's our goal. So I'm going to make an IF stream to do that. And technically, I can just read the first 5 ints inside a given file. And this will work. That's a better idea, I think. So I'll make a new file now called ifstream.cpp. And again, include fstream. I don't think I need string at the moment, but good to be safe. And now, well, I have a bunch of files right now. I have 3, in fact, with numbers inside of them. 1 to 10.txt, 1 to 10 with functions.txt, 1 to 5.txt. Okay, that means I can print stuff based on those files. So I can read any one of them. So let's make our program, or I guess this comment needs to go up here. Let's make our program accept any file that the user wants to give us. So let's get the file name inside of the command line arguments. Just to remember how to use those. So it's argc for how many you got, and then char star argv bracket bracket. So it's a array of C strings, which are really char arrays, because now we know what pointers do. Okay, so let's just pretend the user did it right, and so we have the file name. So char star file name is in argv1, because remember that the name of the program is always the first thing, so it's the second command line argument that will hold the file name, because I want to run the program like this. From the terminal, I want to say /ifstream, and then file name.txt. Okay? And that will allow me to do it because the 1th index of argv will hold the file name, because the program is always index 0. Okay, so that's the file. And this is why it's good, so it works for C++ strings and C strings. That's why we like that. And so now we'll say ifstream, ifs.open, the file name. So open the file the user gave us for reading. And then let's get 5 lines from it and then print the sum. So I want to get exactly 5 lines, I guess. How do I want to do that? Let's see here. I can use a loop. So for 5 times, get a new integer out of this file. And we're reading. It's as if we were saying cin some number n. Int n. It's the number that we're going to read. We can say cin n if the user was typing to us, but the user's not typing to us anymore. We're reading from the file. We can pretend, though, that it was cin and say ifs. Okay, so just pretend it was Cn. Now we have that n, and now we can use it to make a sum. And once we're done reading the file, it's a good practice to close it. All right, so this is the idea. The user is going to give us a file name in the command line arguments. Then we're going to make an IF stream to start reading from the file, open it up, and then we're going to sum together all of the numbers, or the first 5 numbers that live inside that file. Okay? So we're going to get an integer into the variable n from the file, one at a time. It's as if the user was typing to us from the terminal. So we start our sum at 0 as normal, and we get a new integer from the file using that input operator, because it's defined just like it was for Cn. And then, of course, to calculate a sum, we just add to the sum variable. Then we're done with the file, we close it, we can output the sum. So this is all you have to do to read from a file. Okay, so let's take a look at all the files I have with numbers in them, these first 3. I can say /ifstream. And obviously, if I don't give anything, oh, nice. It handled the error very well for me not giving anything. I think took the empty string, didn't read anything at all. That was really nice. But usually we'll give it a file, .txt, and I should have been careful. I should have checked argc if I were a good programmer. So now I'm giving it 1 to 10.txt. It'll read the first 5 lines of it. Okay? And the sum of the first 5 lines is apparently 15. 5 plus 4 plus 3 plus 2 plus 1, which makes sense. And actually, it'll be the same for all of these files, though. But we can give it any of them. With functions.txt, it'll hold 1 to 5 again. The sum is definitely always going to be 15, so we get the first 5 lines. 1 to 5 with functions. Oh, sorry, that's not the name of a file. 1 to 5.txt, sum is 15. So I should have checked argc, but I did not. So that's how you read from a file. Just got to open it and pretend it was Cn. Okay? So I think I'm not so sure on where the time is right now, so maybe I'll give this slide if I can, or I'll just get a setup for this one and I'll come back next lecture for this one. Okay, so what we want to do is read until the file ends. And I guess the question then is, how do we know when the file is over? How do we know how long the file is? And the answer is, you can pretend that your IFS it can be converted to a Boolean value. So it makes sense to say if IFS, which is weird, slash while IFS is the thing that we're going to be using eventually, which is odd because it can turn itself into a Boolean value, and that Boolean value represents whether the file object is okay still. Usually that means whether or not it's read past the end of the file. Let me say this. They stop being true, and okay means true, in C++. So they stop being true, they stop converting to true, and they convert to false instead once you've read past the end of the file. Or you've gotten to the end of the file. Okay, so that is a lot of information, but it's going to make sense. And also you can say ifs.eof. EOF stands for end of file. And that will return true or false if it's read the end of the file, if it's at the end of the file. Okay, so I think that's where I want to leave you right now, and so I'll come back for the next lecture and explain all these words. Or maybe just briefly, if I can, I'll say, I'll find that EOF for you. Here it is. It's a member function of ifstreams. Any object has it. You can say ifs.eof, and it returns you back a Boolean whether or not it's read the end of the file. Okay, so that's where I'll stop, and I'll see you in the next one.